All right, welcome. Today, we're going deep behind the scenes, right into the nerve center of a power plant, to talk about the people who, well, keep our lights on. We're going to explore the day in the life of one of these hidden experts. So let's get into it.
I mean, you do it every single day, right? You walk into a room, you flip a switch, and boom, the lights are on. Your phone starts charging, the TV comes to life, it's just instant. It feels so simple, but what's happening behind the scenes is anything but. Yeah, behind that one little switch, there's this incredible, high-stakes world of massive machinery and precision engineering, and it's all being managed 24/7 by a handful of experts who have our daily lives and millions of dollars of equipment resting squarely on their shoulders. So let's meet this expert. They're called the Control Room Operator, or CRO for short. And honestly, the best way to think about them is like a pilot. But instead of flying a jumbo jet, their cockpit controls an entire power plant, a machine that can power a city. Their job is to fly this thing safely and efficiently, day in and day out. And just look at the scope of what they're responsible for. The CRO is basically the brain of the whole operation. They're sitting in front of the main control system, what's called the DCS, or Distributed Control System, and they see everything. They're not just watching screens, they're actively managing startups, coordinating shutdowns, responding to every single alarm, and they're constantly on the phone with the main power grid and their own maintenance crews. It's a massive, massive job. So, how does a CRO even begin their flight? Well, just like a pilot, it all starts with an absolutely meticulous pre-flight check. You can't just hop in and turn the key on a multi-ton gas turbine. This prep phase, it's one of the most important parts of the whole day. This checklist you see here, it is 100% non-negotiable. The CRO has to confirm that no maintenance work is still going on, and this is critical, that no person is still inside one of the huge turbine compartments. Then they turn to their main screen, the HMI, or human-machine interface, and they have to see a sea of green lights. Those are all the permissives, meaning every single support system, from cooling water to fuel lines, is perfectly lined up and ready to go. Only then can they even think about hitting the start button. Okay, so once all those checks are done, the real show begins. We're talking about taking a massive gas turbine from a dead stop all the way to full power. And this is not a fast process. It's this carefully choreographed sequence of incredible power. Let's break down how you actually wake this giant up. It's really like a four-step dance. First, it cranks up to about 780 RPM and stays there for 11 minutes. That's just to purge any leftover fuel vapors from the system, a huge safety step. Then it actually slows down to fire. Once you have ignition, it starts to accelerate, and it becomes self-sustaining around 60% speed. But that last step, synchronization, that's the most delicate part. At 95% speed, the CRO has to perfectly match the electrical heartbeat of their turbine to the grid before they throw that final breaker and connect. It takes incredible precision. Now, during that whole delicate startup, the CRO is carefully managing things to avoid a disaster called a surge. The best way to picture a surge is like a giant, violent engine backfire, but inside a jet engine. The airflow literally reverses for a split second, and that force can be powerful enough to completely shred the metal blades inside the compressor. It's catastrophic. So they use things like bleed valves to manage the air pressure very, very carefully until it's stable. And this just goes to show you, not all startups are the same. The CRO has to know the condition of the turbine. If it's been offline for more than 32 hours, that's a cold start, and they have to ramp up the power very slowly to avoid stressing the metal. But if it's only been off for a couple hours, it's a hot start, and they can bring it up to speed much faster. It all comes down to their judgment. Okay, so the turbine's online, it's humming along, making power. Is the job done? Oh, not even close. Now comes the real marathon part of the job. Just constant vigilance, watching everything and solving problems before they become big problems. Here's a perfect example of that proactive work. A gas turbine is basically a giant jet engine that breathes in tons of air. So over time, the blades get dirty, and that hurts performance. But you can't just shut it down every day for a car wash. So what do? Well, the CRO actually has two choices. They can do an online wash. This is amazing. They can actually clean it while it's still running. It takes about 30 minutes, and it's great for preventative maintenance. But if performance really starts to drop, say by about 10%, then they have to schedule a full offline wash, which means a total shutdown and a much more involved cleaning process. The CRO has to know which tool to use and when. So let's talk about a more urgent issue. Imagine an alarm starts blaring. the main fuel gas pressure feeding the turbine is suddenly dropping. Now, this is a big deal. This could trip the entire plant offline if they don't act fast. So what does the CRO do? Well, first, they don't panic. They start troubleshooting, step by step. Is it an external issue? They get on the phone with the gas supplier while immediately reducing the turbine's power output to save fuel. If it's not that, maybe it's an internal valve that's stuck. They'll send a field operator to go check it out, and again, they're reducing the load. The key here is their first move is always to stabilize the system, get it under control, and then figure out what the root cause is.
Now, just as much skill goes into landing this giant as getting it into the air. Shutting down a power plant isn't just flipping an off switch. It's a slow, deliberate, and incredibly important process. And this might blow your mind, but a proper, controlled cool down, especially for a big steam turbine, can take up to 3 days, 72 hours. If you try to rush it, you can cause massive thermal stress that can crack or warp multi-million-dollar parts. So for the CRO, patience and procedure are everything. And here's a perfect example of why that procedure is so important. After you shut down, that huge metal rotor inside is still incredibly hot. If you just let it sit there, the top cools faster than the bottom, and gravity will literally cause that massive shaft to sag and bend. So what happens if you don't handle that correctly? The consequence is a mandatory 48-hour wait. That's 2 full days of downtime. If that rotor isn't kept on a slow, continuous spin, it's called a turning gear, until it cools down perfectly evenly, it can develop what's known as a shaft bow. And trying to restart a turbine with a bent shaft? Well, that would be catastrophic. The CRO's job isn't over until the machine is safely tucked in for the night, so to speak.
So when you really boil it all down, what is a control room operator? They are so much more than someone who just pushes buttons. They're a master of incredibly complex procedures. They are a vigilant monitor of thousands of data points every second. They have to be a calm, decisive troubleshooter under immense pressure. And really, they're the guardian of a multi-million-dollar asset that we all depend on. It's just an incredible amount of responsibility, and it all happens completely out of sight. So maybe the next time you flip that switch and your world lights up, you'll take just a second to